Even if our body is not a neutrino, would it be free from the influence of gravity if it were assumed to have no electrical charge, or if it had a neutral charge? No, that's not correct. Gravity is a force that acts on all objects regardless of their charge. Gravity is the force between two objects with mass, and it is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Therefore, even objects without charge are influenced by gravity if they have mass. Our bodies are composed of matter with charge, but they are electrically neutral due to a balanced distribution of charge. However, because our bodies have mass, they are still affected by gravity. Therefore, even if our bodies do not have a net charge, they cannot be free from the influence of gravity. The only entities that can be free from the influence of gravity are those without mass. Objects with no mass do not distort space, so they neither exert gravitational force on other objects nor experience gravitational force from other objects. Neutrinos have very small mass, but they are not entirely without mass, so they are still subject to the influence of gravity. Does massless matter exist? The existence of matter without mass has not been conclusively established. However, particles such as light, photons, and neutrinos are known to have extremely small or negligible mass. Light is considered to have a mass of 0. It is a form of electromagnetic wave composed of oscillations in electric and magnetic fields. Although electric and magnetic fields have mass, light is thought to have 0 mass due to the extremely rapid oscillations of the electric and magnetic fields. Neutrinos have a very small mass, although it is not precisely measured. Neutrinos are electrically neutral elementary particles that are abundant in the universe. While their mass is small, it is not entirely negligible, and they are believed to experience minimal influence from gravity. Therefore, the possibility of the existence of matter without mass is considered. However, further research is necessary to determine whether matter without mass truly exists. If matter without mass does exist, it could contribute to a better understanding of the laws of gravity. Additionally, it may play a crucial role in comprehending the structure and evolutionary processes of the universe. Does antimatter have mass? Yes, antimatter also has mass. Antimatter possesses the same mass as regular matter but carries an opposite charge. For instance, the positron, which is the antimatter counterpart of the electron, has the same mass as an electron but a positive charge. The mass of antimatter is identical to that of regular matter. When matter and antimatter come into contact, they annihilate each other, converting their mass into energy. This annihilation process follows Einstein's famous equation, E equals mc squared, where mass is converted into energy. Antimatter is extremely rare in the universe, but it can be created in particle accelerators, and traces of antimatter have been detected in cosmic rays. Therefore, antimatter can be considered a type of matter with mass. So, do substances with 0 charge also exist? Yes, materials with a charge of 0 exist. Materials with a charge of 0 have an equal number of electrons and protons. Such materials are referred to as neutral substances. Atoms, the basic units of matter, are composed of protons, neutrons, and electrons. Protons carry a positive charge, electrons carry a negative charge, and neutrons are electrically neutral. When the number of protons equals the number of electrons in an atom, the atom is electrically neutral. Therefore, substances composed of atoms with an equal number of protons and electrons are electrically neutral. For example, a hydrogen atom consists of 1 proton and 1 electron. Consequently, a substance composed of hydrogen atoms is electrically neutral. Additionally, neutrons are elementary particles that are electrically neutral. Neutrons are known to be abundant in the universe. Hence, materials with a charge of 0 do exist and can take various forms. Are there substances other than electrons and protons that exist only as neutrons? Yes, there are materials that consist solely of neutrons, and these are known as neutron stars. Neutron stars are formed as remnants of supernova explosions, which are extremely bright explosions resulting from the collapse of a star's core. The remnants of a supernova explosion are composed of neutrons and electrons. When the density of neutrons becomes extremely high, a neutron star is formed. Neutron stars are very hot and have an extremely high density. The surface temperature of a neutron star is around 1 million degrees, and the density can reach up to 10 billion tons per cc. Neutron stars experience significant gravitational forces, causing them to rotate at extremely high speeds. The rotation speed of a neutron star can be thousands of rotations per second. Neutron stars are rare in the universe, but their existence plays a crucial role in astrophysics research. The presence of neutron stars helps us understand the evolutionary processes of stars. Additionally, since neutron stars have one of the highest densities in the universe, studying them can contribute to a better understanding of the fundamental structure of matter.